That's the SSID. Then that's the password, Telefónica 456, lowercase. And then the last one is the stream for this, if you want to share it with your mom or whatever, the ones that who are speaking. We will be streaming today. This is the only day we will be streaming. But I think it's a good opportunity to I don't know, to in a way make this a little bit more public. The keynotes by Ricardo and by Janos, they're going to be streamed, and then they're going to be recorded as well. I'm going to put them online at some point and give them to them as a gift in a way. I think that should be it. I hope that the network works better now. I know we're in the Telefónica building, which, believe me, we'll get it working at some point. Yeah, oh, one more thing. For the lunch, if you go to the Welcu, W-E-L-C-U, the one that you got the ticket from, there's a map there with a lot of restaurants that you can go to that are very close by and quite good. Let's get started. We're right on time, which is kind of interesting. Yeah. So maybe Jorge wants to come and take over. Yeah. And you can just turn the video to the No, eso está bien. So, Rodrigo, if you want to change the...
Okay, everyone, thank you. Now we have 4 talks, 15 minutes each. So I don't want to take away time for our speakers. So the first presentation is Mariano. He will talk about topic-based study of Twitter political network. So please welcome, Mariano.
Well, thank you very much. So, well, I'm Mariano Beiró from Universidad de Buenos Aires and CONICET in Argentina, and I will present this work, a topic-based study of a Twitter political network made in collaboration with Tomás Musi Reyero and José Ignacio Álvarez Amelino, also from Argentina. So, this work is about the presidential elections in Argentina in 2015. So that I will begin by speaking a little about the political context of the elections and the data that we use for the study. Then I will briefly describe the methodology. I will omit some technical details, but will give a general picture of what we did. And finally, I will show you some results. These are in some way pre-results, and we are still working with this project. And I will mention some of the conclusions that we arrived. So the political context, which is important to understand. So in 2015 in Argentina, the president was Cristina Fernández de Kirchner, who had been elected twice. She came from the Peronism, from the right wing, which is from the left wing, sorry, which is a classical party in Argentina since the 50s. And she was in the power during 8 years. She was elected twice. So in 2015, she was not eligible as a candidate. So there were 2 main candidates at that moment, Mauricio Macri and Daniel Scioli. Daniel Scioli in some way represented the continuity with the previous government. He was also from the left wing. He was like the chosen by Cristina Kirchner. And their movement was called like National and Popular. They sustained anti-liberal politics, in some ways protectionist politics. And in the last time of their government, she had been criticized because some denounces of corruption and money laundering, and for omitting statistics of inflation and poverty. I mean, that were the main critics during the last time of her government. So in some way, Daniel Scioli represented the continuity with that project. On the other hand, Mauricio Macri came from the right wing, from a family of entrepreneurs, and she was proposing to reform the country, to reduce the public expenditure, and to make a strong reform and fight against corruption. And he had a large team of economists and politicians ready to work for him in this new project. On the other hand, there were 2 alternative candidates, Sergio Massa and Margarita Stolbizer. They were not that as important in the first moment. Sergio Massa was also from the left wing. He was also a Peronist, but he was trying to fight against some of the problems of the government. He was also denouncing corruption and was recognizing that there were several things that had to be changed. And finally, Margarita Stolbizer, who did not get to manage a large number of votes, but also represented another classical party in Argentina, which was a progressist and from the right wing. And in fact, she wrote a book about corruption during the government of Cristina Kirchner. So the results in the first round of the elections were with Daniel Scioli in the first place, 37%, but he could not get to the presidency yet because he did not manage to get a 45%, so they went to a ballotage between Mauricio Macri and Daniel Scioli. So the first round was in October 2015, and the ballotage took place in November. And the main question was, what would happen with these people, with the 21% of Sergio Massa? I mean, would they vote for the left, or would they also vote for a change in the country? And the result was that they voted for a change, and in the end, the final result of the ballotage was 51% for Mauricio Macri and 49% with Daniel Scioli. So I will try to understand with some data from Twitter if we can get to see how this was possible during the last months between the first round and the ballotage. So we will analyze the accounts of many followers of the candidates in Twitter. This is just a rough description of what we did. So we analyzed 300,000 users with interest in politics in Argentina, and in fact, several million follower-followed relationships between them. It contains more than 50 million tweets in the period August 2015 to March 2016. So that was the data set. And now the methodology. So this is a typical tweet with some text, user identified. It might contain some hashtag, it might be a retweet, and it will contain the timestamp somewhere. So the first thing that we did was to build a hashtag co-occurrence network where we say, for example, that hashtag US appeared together with hashtag Democrats 305 times, and we put that in this matrix. So, of course, just a side note, I'm putting these examples in English and with English hashtags and contents, but of course that the real data that we have is mainly in Spanish and is part of Argentinian users. So we have this hashtag co-occurrence matrix, and from this matrix we can build, or we can think about it as a weighted graph in which nodes are the hashtags and the weighted edges between the hashtags represent the co-occurrence of hashes. To this weighted graph, we apply a community detection technique, which is the OSLOM algorithm for detecting significant communities, and we will detect 2,400 communities that we will call topics because they are associations of hashtags with semantical similarity. So we have these 2,400 topics, and we will try to see what users were talking about in this topic. So I will show you a couple of the internal structure of a topic. This is one of the topics most related with Mauricio Macri, the right-wing candidate, with hashtags like I will vote for Macri or Macri president. And another topic related with Massa, the alternative candidate, like, again, I will vote Massa, Massa will defeat Scioli. So we observed that these topics were really representative of the interest of people in politics and in other topics, in other arguments also. Now, let's put bring the users into scene. So now we have the users. We have this, for example, this lady there that she used the hashtag tractor 5 times. So we will put the hashtags belonging to the same topic together. And by summing them, we will say that, for example, that lady talked 7 times about topic 1, 1 time about topic 2, or the second lady talked 25 times about topic 2, for example. We will normalize these vectors. We will apply the TF-IDF transformation, and we will apply normal 2 to each of the users, and we will have a user topic matrix like this one, where each user will be identified by a user vector representing his or her interests. For example, in this case of this lady, her main interest is topic number 2. So that is what we will call the user vector. And by comparing these user vectors, we can analyze phenomena like, for example, homophily. That is, that people that have similar interests tend to be connected. And in fact, we can plot that in a graph like this one, where we can observe that people that follow themselves tend to have higher similarity values than people taken at random in the network. Well, I will not concentrate on this, but now I will use this similarity in order to understand how the groups evolved during the elections. So how do we measure similarity between these users? Well, we will take the user vectors and we will apply the cosine similarity to the vectors. That is, the dot product between the user vectors represented two people. We can do this also between groups of users. That is, I can take group G1 and group G2 and compute the matrix product between the user vectors of the people inside each group. And I will get a bunch of similarity values. I will make an histogram, and I will take the mean similarity between these two groups. So I will call it the cross similarity between G1 and G2. And I could also do this for a group and itself. I mean, the self-similarity of a group with of the members of the group. And I will, in fact, do it in briefly. So the last piece that I have to explain is how we track the temporal evolution of the users. So we have all the tweets of the users during these 9 months, and we will analyze by periods of 10 days. So I will take a window of 10 days and concentrate only on the tweets written during those 10 days. And I will build a user topic matrix on those 10 days. So the topics are detected just once, and they are static during the whole period. But the user topic matrix will change for each time slot. So I will try to track the interest of the people during the whole period by 10-day windows using a sliding window technique. So let's go back to the groups. I said that these users had interest in politics, so that they were following one or more of the political candidates. So I identified the candidates with the colors. So Macri was the yellow one, Scioli was the light blue one. So I will separate the groups of users in those following Macri, those following Scioli, following Massa in black, and Stolbizer in pink. And for these 4 groups, I will track the internal similarity of these groups during time. That is, how similar these users were between themselves or among themselves during the whole period. And now I will show you a real plot of what we obtained. And the first result, or the general picture that we have, is something like this, which has a lot of elements to explain. I will just mention 2 or 3 of them. But for example, I don't know if this works. For example, on the first round, on the day of the first round on the left, what you can see is that the 4 groups are quite active. Their similarity has a high value. After the first round, the internal similarity for the groups following Massa and Stolbizer gets down. And we only have high values for Macri and Scioli, who are the ones that are still running for the presidency. Another interesting aspect, for example, is at the beginning of October, where Macri and Stolbizer, the yellow and pink ones, have high values. And that is representing the moment of a public debate between the candidates that was very famous in Argentina. And in particular, Scioli did not take part in that debate because she just not accepted to answer that debate. So he had almost a 0 value in that moment, while Macri and Stolbizer had very high values. Now, a more interesting picture that we have is when we analyze groups against themselves. For example, the similarity between followers of Macri and followers of Scioli, which is pictured in brown here. So what this picture tells us is that Macri followers and Scioli followers have negative similarity values. That is, that we can observe from the Twitter data that they are really representing indifferent or opposite content, while the internal similarity inside each group is positive. And the last plot that we have is one that compares the similarity of the Massa followers and the Stolbizer followers against those groups of the main candidates. And that's one of the most interesting things that we observed, because in particular, we were interested in understanding what happened with the Massa followers and how they managed to turn over the election by voting for Macri. So remember that Massa, the candidate with the black box, was from the left wing, as Daniel Scioli, as the other candidate. But when we compare the similarity of the Massa followers with Macri and Scioli, with the yellow voters and the light blue voters, the highest values are with the yellow voters, and in particular, after the first round and before the ballotage. And what this picture tells us is that after the first round, once Massa was already was not running anymore, all its voters turned into Mauricio Macri. And this is an interesting phenomenon because it is followers of a left candidate deciding to vote for a right candidate after their candidate is out of the elections. And that is surprising. And we could detect it after the first round, while in Argentina it was a hot topic of discussion during all the month of November. The question was, what would these candidates do in the ballotage? On the other hand, on the lower picture for Margarita Stolbizer, the situation is much more clearer because the similarity of her followers is always positive with Macri and almost always negative with Scioli, which is clearly expressing that their interests were from the right and not from the left. So during all the period, they were more similar to Macri. But for Massa, it is very interesting that before the first round, they had negative similarity with everyone, and after the first round and before the election, there was a sharp turnover in which they expressed that they really wanted a change, and instead of voting for the left-wing candidate, they decided to vote for a change. And we could analyze it from Twitter data. So the conclusions that we extracted was that we could detect topics of discussion by observing communities in the hashtag network. We found that these topics were representative of the political interests of the people following the candidates. And finally, we were able to explain in some degree the ballotage results from the change of opinion expressed by the voters of the alternative candidates, in particular Sergio Massa. Well, thank you very much. No sé cómo estuvo el video.
So we have time for two questions, one or two questions.
Thank you, Mariano. I have a question related to something you said at the beginning, because in the last, let's say, 3 or 4 elections where you had the ballotage, there were a lot of new voters coming. So I think in Chile were like 1 million more that vote. So did that happen in Argentina too? Because sometimes you say, okay, this 21% will go to one of the things, but also there's
Yes.
a lot of people coming that didn't vote the first time because they knew that no one will win. So they're waiting, they're lazy, they were waiting the next round.
Okay, I'm not sure. I don't have the number. I don't know if there were much more users getting in. What I can say is that voting is mandatory in Argentina. I don't know if in Chile the situation is the same, but it's mandatory. So the ones that are not voting either in the first election or in the ballotage, they are breaking the law in some way. I mean, so it's not a large. Okay, I mean, in difference with other countries, in our country it's mandatory to vote. I don't know how many people really got into the elections in the ballotage.
You have to turn it on, though. Yeah.
Uh-huh.
Yes. So you said that the voters of Massa turned to Macri after the first round, and in your graph it appears to already happen before.
Yes,
That's
there.
something that you have looked into.
Okay, thanks for your question. So, well, 2 points. When I say that people from Massa turned into Macri, maybe I should have expressed like most of them turned into Macri, because if you see Scioli had 37 and it passed to 49, while Macri had 34 and passed to 51, so that most of Massa followers turned into Macri. Not all of them, maybe I misexpressed it, but most of them, and indeed they managed to turn around the question. The other question that you are making about the moment before, well, there are several factors. One of them is the sliding window mechanism that we have, because for each point of time, we are representing 5 days before and 5 days after the election. So I think it's mainly related with that. But I mean, also maybe situations like what people do on weekends, I mean, on the weekend of the election in particular. But I mean, that point there might be represented 5 days before and after. What we were surprised to find was that sharp change in opinion just in the day of the ballotage. Well, thank you.
We have time for just one more question.
I wanted to ask you if you have any way of determining, because what this graph might mean is simply more than sort of agreement between the second-tier candidates with the top candidate, rejection of another. And in Argentina and in many countries, this plays a very big role, that you vote not because you particularly choose one of those candidates, but because you particularly want the other one to succeed. And this might go both ways. Is there any way for you to try to determine between those two things?
I think that there might be. We did not put attention into that, but I think it might be. And in fact, in Argentina, that was the case. They were expressing that they did not want anymore that, and maybe they are today also not conform with the current situation, but at that moment they said, we wanted a change. That was the change prevailing to their orientation, to their political orientation. I think that might be a way by exploring the topics and the hashtags and trying to extract from the topics what is the main information. I mean, what they are saying. Are they saying, I mean, if they were not so similar to Macri before and after the first round they become similar, I think that that might be expressing that it's just that they are similar because they are preferring that to the other election. But I mean, I think that there are many ways to track that with this type of data from Twitter. And that it would be interesting, for example, to analyze what happened during the the following years, when many people got also deception from the new government. I mean, they wanted a change, but they also didn't happen to agree on the new politics either. So the situation was not resolved after this election. So I think it's possible.
Thank you, Mariano. We are on time, so thank you very much. You got Hannah. Next speaker. So the next speaker is Mauricio Quesada. So you have 15 minutes.
Hello, good morning. So this is a work we did a few years ago. So it was initially funded by Yahoo, but now Barbara and I are part of the Millennium Institute of Foundational Research and Data. And Janani and Gert are from University of California, San Diego. So this work is about prediction and characterization of high activity news events in social media triggered by real world news. So we study social media as a means of produce and to consume content. So with the smartphones and with the appearances of applications, so we have now low barriers to produce content and to consume content. So but what we want to study is about the impact of news events that had on social media, based on the content that was produced on social media. So social networks are used nowadays as news sources. So this is a little statistic about the usage of some platforms as news sources. So Reddit is the most used, although only a few percentage of the population use that platform. But for example, Facebook and Twitter are very used and are very popular. So to motivate a little further, this was one of the first tweets that reported some news event before the traditional media. So this was about a plane that had to do an emergency landing, and some of the one person that was in I think in a ferry nearby saw that and took a picture with their phone and published on Twitter, and this will become popular. This tweet became popular. It had a lot of shares and so on. So what we want to study is how to define or what is the impact of an event. So for example, this picture caused some sort of impact on the network. So we want to define what is impact in the physical world or what is impact in the virtual world, and how to measure it, how to define it. So for example, we have one of this event was the death of Nelson Mandela. So it was a breaking event in that time with global coverage and a high volume of reaction on social media. So one can say that this event caused an impact on the social network because it has a lot of shares, a lot of posts about it. So it was a very popular event. However, what happens about local events? So this was about in 2013, Chilean presidential candidate, Pablo Longueira, resigned from the election because of alleged psychological problems. And this was a high impact event, but in a local network. So it was about in Chile. It didn't have a lot of shares or a lot of posts about it, but nevertheless, it caused some kind of impact. So we can measure it about the number of posts, for example. So our goals are about filter and rank information that will have a high collective impact on social media, and then to characterize and predict these kind of events that will cause some kind of impact at a global and a local scale, and to understand information dynamics. So how do we model events? First of all, we have a high-level abstraction. We have an aggregate view of the messages. We don't consider, for example, one piece of information. We include all the content about it, so text, images, links, and we focus on real-world occurrences, in this case, news events. So to make the distinction, we focus on events and not memes. So we understand that memes as a unit of information that comes from a single source. But in our case, we focus on events. The events comes from multiple sources. So it can come, for example, from a witness of the event taking a picture with their phones, or for example, from news sources. From, I don't know, I read the article on the internet and then I share it in Twitter, for example. And about inside of the social network, people commenting about it. So we have multiple sources, different kind of contents, and different formats. So how do we model impact? And first of all, how do we define impact? What is impact, really? So how much impact the death of Nelson Mandela had on the social network, and how much impact the resign of Pablo Longueira had in the social network. So what we do is to concentrate on the strength and the immediacy of the collective reaction of users. So instead of talking about impact, we're going to talk about activity. And we will use the level of activity in social media as a proxy for impact. So our proposal is about to model the level of activity of events. And we have what we called in the paper the VQ event model. But what we want to do is to identify events with similar distributions. So we can compare different events of different scales and different levels of popularity and so on. So for that, our model tries to create a common representation of events so we can compare them. And what we do is to take the inter-arrival times between consecutive posts. So the vector quantization part is about how do we take all these inter-arrival times and transform them to a common space. And this is related to the event size. So what we want to do is to try to compare the death of Nelson Mandela with the resignation of Pablo Longueira, in this case, for example. So this is a histogram of the inter-arrival times. So the inter-arrival times are the delay between consecutive posts. So for example, I take all the tweets about the death of Nelson Mandela, I sort them in published times, and then I take the difference between the creation time between the first tweet and the second tweet, and then the second tweet and the third tweet, and so on. So we take all those differences in time, put in a histogram, and we have something like this. In this case, we restricted this plot to 60 seconds, so it seems like the distributions are comparable, but they can extend to minutes, hours, or even days between consecutive posts. And we can see the difference between the distributions. So for example, the second plot is about one event that happened, I think, 1 or 2 weeks after the Oscars, but the event was still talking about the Oscars. So the distributions are very different. So in this example, for the death of Nelson Mandela, in the first bin, the 0.01 seconds, correspond to the proportion of tweets that were in less than a second of difference between them. And for example, the last bin corresponds to the amount of tweets that had at least 60 seconds of difference between them. So in our experiment, we took 1 year of a data set of 1 year tweets. So we have 5,000 events, 43 million tweets. What we did to collect the tweets, so we had a lot of seed accounts. So for example, CNN, BBC News, Breaking News, and so on. We have a selected list of, I think, 80 accounts. So we used them as seeds. So we took all the headlines or the tweets that those accounts published, and then we took all these headlines or these news reports, and we identify relevant keywords and use those keywords. I think the picture is is better. So in a fixed time t, we detect the keywords from the headlines. So for example, in this case, we have Martin Jonathan and airlines missing, Malaysia Air, and so on. And with those keywords, we go to the Twitter search API again, and we collect tweets about those keywords. And then 1 hour later, in this case, we repeat the process. So we have a lot of tweets corresponding to, for example, a couple of keywords. So what we do next is to use those keywords and the corresponding tweets to group them and to create the events. So what we do is to see the common keywords between those sets. So for example, the Malaysia flight and missing flight, we join them into Malaysia flight missing, and Malaysia Air, and so on. So we have these like kind of graphs that we want, but that we had to clean them after doing this process because there are some words that are like hubs. So for example, police group a lot of other keywords. With this collection of data, so for example, we have an event. So those are the keywords and some example tweets. So this is about the soccer player Luis Suarez biting another player in the 2014 World Cup. So with that data set, so what we do is to create the representation. So this is the first example I showed to you. So this is the histogram of the Nelson Mandela and the Oscars, and the histogram can be much larger than that. This is restricted to the first 60 seconds. So what we do is to first take the inter-arrival times of the entire data set. Then we find the most common differences across the entire data set. And we use those common differences as beans of a new histogram. And then we use vector quantization to take the original distribution. So for example, we take this distribution and then quantize it to the found beans that we found by clustering. So we have the original histogram, and then we transfer them to the new representation, and with the same with the Oscars. So we have the same representation. If the beans are are fixed. So this is not clearly a histogram, but it's a vector, a bar chart. And now the distributions are comparable. So we can then compare the distribution of Nelson Mandela with the Oscars. What we do next is take all the events that we have in our collection with this new representation and then assign them categories. So what we do is to apply clustering again and find the different categories of activity. So we found, in this case, 4 categories using 4 clusters. And then the first one is the high activity. Then I think I can do this. Yeah. No, okay. Then we have the medium high and medium low and low activity. So you can see in the high activity, most of the proportion, most of the tweets in that group focus on the first bin. And the medium high is less concentrated in the first bin and more in the second, and so on. And the last category is evenly spread across all the bins. So for show some examples, those are high activity events. So we have the death of Nelson Mandela. It has 100,000 tweets. So this is about 80% of high activity concentration. On the other hand, we have another event. There was a gang rape in Mumbai. It had 1,000, 2,000 tweets. It was much less. But the 50% of those tweets were concentrated in the high activity events. But in the second event, the following day's repercussion was about 12,000 tweets. So it caused a more repercussion in the following events of the next days. In the low activity events, we have, for example, the first event is about a teen hiding in a plane wheel. And the second event is surveying the damages of a tornado in Canada. So those events were low impact, but they're different. For example, the first event had 18,000 tweets, and the second one was 1,000. So those are this heat map, but in the form of histograms of the high activity and low activity distribution, the categories. So we have clearly different distributions from those. So in this other plot, what we plot is the high activity events in red, and in this kind of blue, the low activity events. So what we see is the first point is like the first bin. So this is a very different distribution. So the 70% of the tweets of high impact, of the category high impact, are in the first bin, in contrast to merely an 8% of the low impact. So the difference is in the first bins. So what we do next is to take some characteristics of high activity events in contrast to low activity events. So we want to find how the information propagates, the conversations, and how focused are the topics. So what we found is that in the high activity events, we have a lot more retweets, more plain forwarding without modifying the content. We have more conversation, more users involved, We have a smaller vocabulary, less hashtags, so we interpret that as a more focused content, more focused events in the high activity category compared to the low activity. So what we do next, so we characterize them and we want to predict them. So we took a lot of features that are not related to the distribution of those events and used them features to classify, to train a classifier. So we took an off-the-shelf classifier and tried and saw what happened. So what we do is to take all the tweets and try to classify them, and then we took the first 5% of the tweets of each event and try to classify them. What we saw that is we have a high precision, so 80%, 95% for non-high activity in this part, using the first 5% of the tweets. So we can predict the category of the entire event using only the 5%. That was an average of 4 hours of development of the event. So to conclude, so it is possible to detect high activity events early, but for some events it requires more data. So in this case, in the non-high activity or the low activity, we had a 99% of recall, but in the high activity we have 45%. So it's pretty low. So what we think is that in some kind of events, we need more data in order to classify them. And the social network was a natural filter to try to identify those kinds of events. Okay, so that's all. So this is a link to the paper if you want to see it. Thank you.
So we have questions now? 5 minutes for questions. Anyone? Any question? No?
No questions?
No questions? So move ahead.
Okay, so let's thanks the speaker again. Thank you very much.
Claudio. So now our next speaker is Claudio Villegas. Esto hay que expandirlo. ¿Cómo se expande? ¿Cómo se expande? ¿Sabes cómo se expande? ¿Cómo se expande esto?
Doble clic.
¿F5? ¿F5? No, not happening.
Not Ubuntu fine.
No. Sí, le apreté.
No, pero junto. No, ok.
Quedó
un color, pero no sé, no importa. Okay. Well, hi everyone, my name is Claudio Villegas. I am a social anthropologist and I am representing me and also Christian Webe, which is the leading researcher of this project. In this project, I am going to talk to you about an adaptive network model that we designed to achieve a continuous representation for analyzing the emergence of echo chambers dynamics. So our motivation in this project is that, well, we see that there is a relationship between these three concepts in which post-truth, that is circumstances in which objective facts are less influential in shaping public opinion, are related to echo chambers that describe situations where beliefs are amplified by a closed community. So the relationship is that post-truth only can emerge when we have strong echo chambers in the interaction system. So there is a strict relationship with this and ideological systems that are systems of ideas and beliefs that appeal to collective action. The relationship is as follows. Ideological systems tend to emerge historically when there is a social crisis. So when we experience lack of social cohesion, we develop ideological systems to confront this crisis and to to achieve some social attachment. So when there is non-opposed ideologies, we have instantaneous consensus and then social attachment, and we see if the problem is solved or not. But by the other hand, we have the outcome that we have two or more opposite ideologies in which we are inside an ideological struggle. This ideological struggle can reach consensus and then social attachment, or can reach echo chambers and then social fragmentation, and then social fragmentation leads to post-truth politics, but post-truth politics also deepen social fragmentation and also social crisis. So what mechanisms leads to these outcomes and how we represent this process is what we are answered in this investigation. We are inspired in a previous work developed by Christian Webbe, among others investigators, in which they're designing a directed adaptive border model. In directed adaptive border model, we did consider a network of n nodes and key directed connections. Each node can be in one of two opposing states that are binary. Then we initialize the network with random states sigma y and connections, and we impose an outgoing degree distribution and average degree k. So in every time step of the model, we select a link at random. If the nodes that are connected by the link have the same opinion, then nothing happens and the link is null. But if they have the different opinion, then we have, with probability p, node y is linked to a random node with the same opinion as him and cuts the link y to j. And with probability 1 minus p, node y change opinions from sigma y to sigma j, imitating their neighbor. In this model that can reach two absorbing states that are consensus or fragmentation, we can see that with low key, we can achieve fragmentation for a broad range of p parameter. So the cause of this is that with low key, we have an excess of nodes with few information sources that we can see, which is the same situation that we can see in internet networks. So the fragmentation mechanism implies that the formation of these echo chambers that we can see in here are formed early in the dynamics. Then these groups never change opinion because they follow only those that are with the same opinion as them, so they are in a stable structure. Then they influence connected nodes in the dynamic, and fragmentation is produced because this kind of a structure can only grow. Then we have achieved a post-truth emergence. In this sense, we ask what can happen if we have, instead of a binary representation, a continuous one? Well, the objective of this project is to characterize echo chamber formation and dynamics in continuous opinion case, and the methodology is to extend discrete model fragmentation results to continuous opinion case. Then we design this model in a way that opinions sigma y range not from not in a binary fashion, but in a continuous rank from -1 to +1. Then the model dynamics is that if the absolute difference between the opinion of connected nodes are larger than the beta parameter, then we say that the link is active. With probability p, the node is linked to a random node with an absolute difference of opinion smaller or equal than the parameter beta, and with probability 1 minus p, the opinion is updated the opinion of the node is updated according to the following equation, which is just weighted average. In this sense, the alpha parameter can represent, in the weighted equation, can represent opinion drift due to influence. Then low alpha can represent critical thinking. And beta can represent something as tolerance to diversity. In this sense, our experiment design is quite simple because we imitate the conditions in which the discrete case achieves fragmentation for a broad range of parameter p. The results of this work, which is a work in progress, is that we achieve novel final states, which is this which can be classified as fragmented and non-fragmented. In the fragmented case, we have this polarized zone in which which is the same as the discrete case, but we have also this kind of gray component, which are populated by moderate nodes near to zero opinion, that isolates a group of extremist nodes. In this case, I think there are 3 islands. In the non-fragmented cases, we have this kind of structure, which is a semi-polarization, which mimics this polarized state, but connects the component by a few centrist nodes. We have also organized diversity, which is this component that populates the ideological space in similar densities. And we have this disorganized diversity, which is everything that is not organized diversity. The typical states that we can see in this model as for p-value equals to 0.5 and in function of alpha and beta parameters is quite diverse, but can be classified with this weak classification that I mentioned above. So in this case, we can see that we have in this model we have a preference for organized or deorganized diversity, and semi-polarization and polarization are just present in the extremist zone. Also, gray fragmentation is very atypical, and I want to mention that consensus, total consensus, whether it be blue or red, are very, very atypical in this model. So there is also noble dependencies of P, what we can see here, in which this, with this fixed condition of alpha parameter 0.9 and beta parameter 0.1, we can see that there are 2 fragmentation zones in which in this area we have a prevalence of this kind of structure, and in this area we have a prevalence of polarized structure. So the kind of fragmentation depends on the combination of parameters. We have 2 novel mechanisms related to this fragmentation behavior. First, we have ideological chain emergence, which is a novel kind of stable structure that presents on this model. Ideological chains are a stable structure which have 0 active links inside it, in which opinions slowly drift away from tolerance of the first node, so allowing possible paths between extremists. In this sense, we have this kind of a structure that populates all of the non-fragmented complex structures that we can reach in this model. So, but also the emergence of ideological chains suppose a natural destabilization of echo chambers, because this kind of when this structure is going to emerge, and a node have to select between rewiring inside an echo chamber or outside it. Well, so when we have higher diversity of options for this rewiring process, then we have lower probability of echo chamber forming. In this case, in this sense, we have to make a question as how diversity emerges. We think that the emergence of diversity is due to this adaptive dissonance interval. Adaptive dissonance interval supposes that a moment when we have only extremists, and when they are going to talk, they imitate each other, but not enough to tolerate each other. So they have to keep talking. And also, previous friends hate each other because they don't like the new position of the nodes. So in this sense, we have a condition, a limit condition of adaptive dissonance for generating this kind of dynamic, in which we are going to call critical thinking, which is when this relationship between 1 minus alpha is larger or equal than parameter beta. So adaptive dissonance have the effect of generating a more dialogue probability with critical thinking that generates the moderation process and destabilizes the fixed structures inside the model, so emerging more ideological diversity, which allows the chaining process, but which is the possible paths between extremities. But Also, we can think that as a loop in which critical thinking generates more dialogue and increases diversity, but allows more diversity only if the system remains connected with change. So if we let diversity to connect, then the system remains stable. Otherwise, it leads to this time-costly consensus that isolates smaller extremist groups, which can be the seeds of future polarization when we arrive at social crisis. So the interaction of these mechanisms can be seen as follows. When we, for example, when we lack of critical thinking, when there is a condition in which 1 minus alpha is smaller than beta parameter, we have more fragmentation cases than when we have the limit of critical thinking, which is in this case. Also, with low intensity of alpha parameter and high beta intensifies the chain emergence in a non-trivial fashion. As we can see, in this case, we can see that with beta parameter of 4 and alpha parameter of 0.3, fragmentation disappears for almost every p-value, and only chips when there is trivial, which is 0.95 or something like that. And also, if we initialize this model as a diversity, if we initialize this model with a diversity initial condition, which is an homogeneous distribution of ideological space, then we can see that fragmentation is controlled for all the all high p-values, because the nodes can use this diversity to connect each other. Besides the incapacity of changing their opinions, but also we have this fragmentation of gray component, because this gray component is independent of the initial ideological distribution. The conclusion of this work in progress are very simple. We can see that a small change of continuous opinion dynamics implies richer results and more realistic component structures. So it is necessary to make a dialogue between experimental social science and experimental biological science to achieve a more opinion rules verification of the model dynamics. And also, we need to contrast these results with more data. But also, it seems like continuous representation of opinion, as we can see as an empirical trait of modern democracies, is a very adaptive trait of political systems, because when we think that there exists not only right-wing and left-wing, but also center-left-wing, center-right-wing, and center, we allow connections of, we allow these ideological connections and allow to the system to work without the fragmentation risk. So, also, we're tempted to say that critical thinking destabilizes both group and content of ideological struggle, allowing diversity. So, when we have this crisis, it is fundamental to societies to make more dialogue between the extremist ones, because this is the only way that we can reach more moderate opinions. Thank you.
So we had time for a couple of questions.
Mm-hmm. Laura?
I was wondering whether there's space in your model for people who are not as engaged. So kind of the no opinion and how that might change the overall data.
Yeah, in fact, I was thinking about it with your presentation. So, no, in this work in progress, we are not representing the neutral nodes or something like that, but we are tempted to say that if we add this kind of nodes, we are going to see novel mechanisms in the polarization process. But for the moment, we are not doing that. Thank you. Mm-hmm. Depending on what?
Depending on the individuals. So individuals who are less,
Yeah.
have less successful on policy, they have a lower chance of rewiring themselves to someone who has a similar characteristic.
Yeah, I think there is a qualitative difference between those who are willing to engage and those who are neutral nodes. But and in that case, we can represent this switching mechanism with a low level. But I think neutral nodes have a structural characteristic, which is that they are surrounded by neutral nodes too. I don't think that someone which is surrounded by neutral nodes is not willing to engage. So, any more questions?
Any more questions? We still have time for one question.
Okay. Thank you very much.